Yeah. Favorite to come up now. TikTok. You know, TikTok is not my favorite, but a lot of people follow on it, so I'm making use of it. Let me see what I look like on TikTok. Yeah. Yes, you do. Yeah, idiot. They want a little bit of delay. Go live. When you say go live, then say plus 45 or that. Alright. And in this one now, choose, learn. Well, TikTok a little bit better because for them about 1, 2, 3, 4, 5, 6, 7 out of 15. Alright, so maybe we have 10 minutes left or less. How many minutes do we have left? Oh, remember that you don't know the time. See them start them crap there already. Okay? Alright. Let's continue. The one says, the coordinates of the points A and B are such and such. Determine the equation of the perpendicular bisector of AB. Tell me what you're going to do for that before I start. Let's go.
First you find the gradient, so y2 minus y1
Yeah.
over x2 minus x1.
Okay, so you need to find the gradient first. So n is equal to negative 5 minus negative 3 over negative 10 minus 2, right?
Yes, sir.
So that is going to give you what?
Negative 2 over 8.
Negative 2 over 12?
Oh,
No.
it's negative 10.
Over negative 12,
Yes, sir.
which is equal to 1/6.
And the perpendicular gradient would be negative 6.
And then what you need for perpendicular bisector? Midpoint it is the bisector. That means it must be halfway between them, bisector. Yes. So, what do we say now? 2 plus negative 10 over 2. What else? Negative 3 minus 5 over 2. So the midpoint is going to be what? This is going to be negative 10 over, this is going to be negative 8 over 2, right?
Yes, sir.
Negative 4, because that's negative 2. So y minus the value of y, that's what I'm using, right? Is equal to gradient.
Yes, sir. You're using this slope.
I'm not using y is equal to mx plus c. I'm using y minus the value of y is equal to gradient x minus the value of x.
I know, sir, but there's a specific name that they have.
The general form, the general equation of a straight line.
No, sir, it was another name. I don't remember.
For this one,
Yes, sir.
I don't remember calling it. But I remember calling the y is equal to mx plus c, the general equation.
Okay.
Yes. So what do we say now? Y plus 4 is equal to negative, is minus 4 here now, is equal to negative 6x plus 4. So what do we say? Y is equal to negative 6x minus 24 minus 4. So y is equal to negative 6x minus 28. Number 3. What did number 3 say?
The line 7x minus 4y plus 25 equals 0, and 3x minus y minus 5 equals 0.
Yes.
Intersect at P. Find the coordinates of P.
So write them, like, just write them the same way that they gave them to us, right?
Yes.
7x minus 4y plus 25? 7x minus 4y,
Plus 25.
yes, equals 0, and the other one is what?
3x minus y minus 5 equals 0.
3x minus y
Minus 5.
is equal to 0.
Yes, sir.
Just multiply equation 2 by 4. Just call them equation 1 and equation 2. Equation 2 times 4, what do we get? 12x minus 4y minus 20 is equal to 0, and that is our equation 3. Do we say equation 3 minus equation 1, or equation 1 minus equation 3?
Equation 3 minus equation 1.
This is still of negative number. In equation 3 minus equation 1, what happens? These are going to go away, right?
Yes, sir.
And then this minus is going to get 5x, that's right?
Yes, sir.
And it's going to be minus 45 is equal to 0, so x is equal to 5, y is equal to what?
9.
No, x is equal to 9. X is equal to 9. X is equal to 9. Into which equation I'm going to put that into? Into equation 2. What do we get?
27.
3 9, you get there? Minus y minus 5 is equal to 0, right?
Yes, sir.
So y is equal to 22. So they ask you for the point. So the point is what?
9.
The point is, no, yes,
9.
9, 22. So I'm showing you that it's not so bad. Right?
Yes, sir.
So I'm going to be looking at number 5 if we have time. Yeah, maths man, you know, this computer. This computer get off of the head, you know. You know, say it's 5:55 still. I can't tell the time, you know. Alright, I'm going to do another one. At least they cannot say that I'm not here. You understand? So this is number 5, this is the last one that I'm going to do in the meantime. Determine the value of k such that the lines this and this are perpendicular.
First, we turn them into the slope intercept.
And what's the next one?
Next one is kx plus 2y equals 12.
You want to write, you want to transpose and make y the subject of the formula?
Yes, sir.
You don't really have to, you know, but as long as you can extract the y coefficient. Alright, so let's go. Let's write it. We have 3y is equal to negative x plus 6. So y is equal to negative x over 3 plus 2. That's correct?
Yes, sir.
Then what? 2y is equal to negative kx plus 12. So y is equal to negative k over 2x plus 6, correct?
Yes.
What is that kx? What is this? Oh yeah. What do we have here? Kx,
Yes.
negative kx, negative kx plus 12, right? So what do we say now?
Gradient for the first equation is negative opposite.
Eh?
The gradient for the first equation is negative 1/3. So that means that what happens is that you can cancel.
That means negative k over 2 is equal to 3 then. They're perpendicular, right? So k is equal to negative 6, that's right?
Yes, sir.
Watch this one now. Negative 1/3, negative k over 2 is equal to negative 1.
Oh, I'm supposed to do it, sir?
Yeah, because we can say, all right, if the gradient is negative 1/3, that means this gradient must be 3 then, correct?
Yes, sir.
Or, that is one way of doing it. Or, we are going to take the gradient for this is negative 1/3, and the gradient for this is negative k over 2. Yes. But when you multiply them, you should get negative 1.
Yes, sir.
Alright, because when you multiply a gradient of perpendicular lines, the result is negative 1.
Yes, sir.
Alright. So, what do we say now then?
Okay.
6. See there, positive k over 6 is equal to negative 1. So k is equal to negative 6. You have to look at, they say that you must look at things in every way. Right, so we just not look at it one way. Close this. I'm trying to cut. This is in way. You don't want to see this in my life again. What else do I do? We have to get the business I'm going into. These books now. Any?
That's one story you want to do.
No, because I'm sure that it's after time now. Yes. Of course, you can manage the equation of a straight line. But let me tell you what. Don't come down here. Come ask me about the equation of a straight line. You should just zip through all of them. Right? So that we don't have to do any more work on it. Because it's not like something that you cannot do. The things that you can do, don't spend any time on them. Saying that we are doing stuff on the board just because we are egotistical. Oh, yeah, it's running all the way down. What a shame. I'm going to fix it right away.
Thank you, sir.
You're welcome. And don't come here next time, come ask me anything about the equation of oscillation. Right? So we can move on to merely and do another topic.
Okay, sir. And you said you're gonna either choose like Sunday or
We can choose any day because what we are going to do is be in dialogue from Sunday, so that, or even from the Saturday night, to say, all right, when can you come in and just do the 2 hours? Yeah, because you're going to have 2 hours in between, so just get it out of the way early in the week as possible. You're welcome. Okay, students. We are just, we should have been started already. What I will do, so that you do not start at 0, but you start on the ground running already, I'm going to put some of the problems, like the ones that you should have done already and get them right, so for us to move on to the next subtopic. So I'm going to erase the board and I'm going to put those problems up. But before I do, I need to say good afternoon or evening to everyone. And I need to say welcome. And I need to say also thank you for joining. I'm saying good evening. I'm saying welcome. And I'm saying thank you all for joining. And believe me, I am enjoying the lesson so far. Yes. And the more I enjoy the lesson, is the more you will enjoy the lesson. Students all, follow in your instructional manuals, follow in your tutorials. You cannot be at a loss. I promise you that I will put some other visuals up, but believe me, what I would call it now, the mishap that I had yesterday has lingering effect, and it's affecting me today also. So let us put some on the board, something on the board that you can enjoy yourselves in the meantime. Students all, do not forget, if you do not follow my instructions, you are going to be in serious trouble. Yes, if you don't follow my instruction, you're going to be in serious trouble. Because every topic that we do is going to be dependent, is going to be required for the next one. So if you do not internalize this one, then you cannot internalize the next one, and you will not be able to internalize the other two. But needless to say, I'm going to put this on the board before I give you your I usually use letters for these problems. A, 4 plus negative 7. B, negative 3. Should I use a larger number? Yes. Negative 10 minus positive, no, it's going to be minus negative 8. 3. Nine minus plus 3. And finally, minus 2 plus positive 5. Nice. I'm taking these from my mind because you know the ones in the book already. What more do you want? A, B, C, D. Nice. I know that students still streaming in. So let us see. Good evening. I'm saying good evening to the students who have said good evening. And for those students who did not say good evening, I say good evening also, so that if nothing at all, you might learn from what we are doing. The person who is asking, what book is this? Do you have any of my books? I see No Evil. Do you have any of my books? The person who is saying, see no evil. The person who is asking, which book is it? I'm not going to answer that. Because if you are familiar with what I am doing and familiar with the work in the book, I'm not supposed to have to tell you which book this is in. Which book do you see problems like those in? Mine is just coming onto the thing, the live thing in the evening, and you don't care. No? Mine, when the class finish in the evenings, you don't read over any book, you don't practice nothing, you don't see anything, you just close the book and throw it away until I come back on the next evening. Because if you're familiar with anything that I'm doing at all, you must know which book this is in. Just look at the problem, you must know. And I'm not going to tell you. You probably see when I take it up. No, and I'm using old resource books, so you might not see. Good evening. And that is 1.111123. So you have any other books? You don't know which book that's in? All right. These problems are not necessarily in the book. But if you look at the type of problems that are on the board, they are similar to the exercises that you have in the book. So you should know which book. I'm going to call you out every time somebody asks me something that you're just ready to waste the time of the other students. Now, what I intend for you to do is take a go at those. And then, just take a go at them. They are not necessarily in your book, but you have, where we were in a particular book the last time, I think I would have finished the exercise, but I'm picking up back there so that we have what we call a continuity. We're just sure of a continuity. We don't really have to do this because we did them last class. But I'm just doing a refresher before we move on to the next subtopic. So let me have the solution of those problems in a few seconds. Okay. So I see the answers coming up. That's nice. Some of them I don't know the answer either. So let's go. And I'm going to discuss each one as I go along. Now the rule that we are applying pertains. The rule. I see another question answers flying for the. Give me the answers for these. I'm only taking the answer for this set. Right. These problems pertain to the consecutive signs, when we have consecutive signs. So when we have consecutive signs, we are going to replace them with one sign. Therefore, this first number is not affected by the rule. So it goes back. So these two signs are unlike. It does not matter which goes before the other. As long as they are unlike, we are going to replace them with a single negative sign. So it does not matter. As long as the signs are different, we replace them with a single negative sign. So what do we have now? We have 4 minus 7. We have to start again at another rule. Right here, apply another rule. What is the rule that we apply here? When we add together numbers that have different signs, we subtract the smaller from the larger. The signs are different. The 4 is positive and the 7 is negative. We subtract. We get 3. And the answer should take the same sign as the larger one. There you go. And yes, of course, the answers are correct. But I didn't see B. It went off the screen before. What's AB? Sir, what's AB? Well, I don't have any AB on the board. What's at B? Oh, what's at B? What's at B? Negative 10 minus negative 8. I'm going to turn on the daylight and see if it helps. I see stuff running on the screen when I turn on the daylight. Yeah, I still see stuff running on the board when I turn on the daylight. So it's best if I stay with the other light. Sorry. Okay, so let's go. So what do we do? Okay, so we're going to have a negative 10 goes back. The light signs are the same. We replace them with a single positive sign. Again, the signs are different, so we subtract. When we subtract, we get 2. The answer will take the same sign as the larger one, which is a negative, so that the answer is negative 2. That one is your favorite from primary school. The 9 goes back. The consecutive signs are different. Because they are different, we replace them with a single negative sign. And of course, there's no one who can get 9 minus 3 wrong. The other one, the negative 2 goes back. The consecutive signs are the same. We replace them with a single positive sign. Again, the signs are different. Maybe the students are giving the answer after I put the one on the board. Let's go. The signs are different, so we subtract. And the answer will take the same sign as the larger, which is a 3. Nice. We go over here. What do we say? The negative 3 goes back. The consecutive signs are like signs. We replace them with a single positive sign. The signs now are different. So we subtract. Because the signs are different, we find the difference. So we subtract. And the answer will take the same sign as the larger number. The 8 goes back. The signs are different. So we are going to replace them. Yes, we are going to replace them. That's right. With a single negative sign. And that one is your favorite. No one can get 8 minus 2 wrong. For the next one, I'm looking for the answer for that one. I don't think that I've seen it. Yes, I think I've seen it. Yes? Let me take a look. No, I've not seen it. It probably is gone already. Come on. Somebody give me the answer for this one. Alright, so what we're going to do is put a negative 6 there. These two consecutive signs are different, so we replace them with a single negative sign. That's very nice, man. That one is very nice. Exacto. So Mr. Cummings and Mr. Todd, and I don't know MOY is what, male or female, I cannot tell, so that's, no, I don't think it's a negative 1. I think it's a negative 11, I see someone, I see. That's very nice, students. You're not applying the rules. You know what that means? That means when you attend class, students, when you attend class, you need to go and revise this stuff. Because if you go into the book and you look at the rule that comes before this, you're going to see where I was adding numbers with the same sign and what I did. But because you're not revising anything, you're not reading over, you're not studying, you're not looking over the book. When you come here now, you give me answers like 1 and negative 1. You're not revising. Here's the next one now. You're not studying. Here's some people say you cannot study mathematics. What do you mean you can't study mathematics? You practice maths. So you practice things where you don't know. The rule says that whenever we add numbers that have the same sign, we add the values. So the numbers have the same sign, so we add them. The answer will take the same sign as the numbers that we have added. So your answer is negative 11. Apply the rule as it is. From institutions where they don't have any concepts to tell you. They give you some to practice. But when you come here, you have a set of theory to learn. You have concepts to learn, you have concepts to apply. When you're adding numbers that have the same sign, you add the values. They have the same sign, you're adding them, you add the values. After you add the values, the answer will take the same sign as the numbers that you have added. Let's move on to the next one. No one can get this one wrong. The 4 goes back. The 4 goes back. These two signs are like signs, so you replace them with a single positive sign. There's no one who can get that one wrong. Students, you better take note of those. Students, you better practice. When I come down here, it's something that is straightforward if you just read and practice. I am not going to ease up on it. You ever hear that one year come yet and I don't finish the syllabus? I'm not going to let you prevent me, because you have students in here who are taking this thing here very seriously. Yes, you have students in here who take this thing seriously. Exactly. Now we are going to move to the next rule. And it's not a rule per se. It's an application of common sense. Alright. As I said, it's an application of common sense. By the time I get up, everybody should have everything on the board already. Not just have it, but also understand. Yes, sir. Look here, skip up. Virgin, all the man they means that. So where is it? No, bring it come here. They don't understand it. Alright. Alright. Okay, sorry about that, students. Okay, as I said before, it's more of an application of common sense than a rule. So let me see if I can find my instructional manual, the old one, and go straight into it. so let's go. Negative 8 plus, I hope that it is that, yes. Negative 8 plus 5 plus 3 minus 12 minus 6 plus 7 plus 5 minus 4. Can anyone find this problem in your book? And I'm not going to tell you which one. So if you have found that problem in your book, let me know. Come on, students. Right. You should not have any difficulty. No, students, let me tell you something. Let me just give you a little lower down. Let me give you a little lower down. Let me give you a little lower down. What I'm doing here now, students, I'm not doing it for me. I'm doing it for you. And I was given the greatest foundation that any human being could get. In mathematics, I received the greatest foundation. I had 2 specialist teachers in primary school, one in grade 5 and 2 specialist mathematics teachers in grade 5 and grade 6. Then when I went to Cornwall College, the mathematics teachers were, you know, on and off, not so good. But when I went to grade 10, Mr. De Bruin was my mathematics teacher. He's the greatest mathematics teacher in the entire world. And then when I entered in the university, I received some of the greatest. People like Shirley, Leslie Robinson, Henry. I received some of the greatest instructors in this subject. Sam McDaniel. So I'm here now, attempting to impart. One thing I never got when they never spoon feed me when I ate it, and I'm very happy. Because I had to stand on my own on a lot of occasions. Yes, I had to stand on my own on a lot of occasions. No, I would have to go to class and write off everything on the book. I didn't have any instructional manual. No, the teacher write instructional manual, you're not allergic to it. I write a set of problems on the board. You can't ask me which instructional manual and which book I'm using today. Because if over the weekend, over the time when you're not in class, you took up the book and you start to work with it, you start to read over, you start to write, you go over back your notes, you revise, you do the concept, you practice some, you go into the homework section for the concept that we have finished already, you do the homework problems. I'm not giving you any homework, you know. I am not giving you any homework because the instructional manual has all of your homework. So as soon as you finish the topic, me must go tell you when you finish topic if you do homework. You must be crazy. You know how many sleepless nights I spend writing these books? So that you can just have the book in your hand and just open it and find the homework. You go on by the back of the book and you see the answers written out in my own handwriting. Everything done for you, all you have to do is learn. And then now I have to come here and force you. No, nobody thinks a Rasta man do that. Me not going to force you to learn. Nothing at all. You see, who take the responsibility upon themselves to learn? may have the responsibility up here to teach already. You have the instructional mathematics book written. How many of you gone on TikTok and try to learn as much as you can from the audiovisuals that I placed there? I have 600 audiovisuals or more on TikTok already. 600 audiovisuals don't even start to scratch the surface of the audiovisuals that I have. They don't begin to scratch the surface. I have over 5,000 animated audiovisual and I still have more. I have the slides for another 500. So the most that you can do, the least that you can do, is just follow. Read, practice, do homework, read over the thing, revise, keep yourself in tune. You have exercises there, read them over, do them over,